Okay, so let me share the screen. Boleh nampak term weighting. So this is the second model after Boolean model. So the reason why they propose this one is that we will be able to perform the document ranking or to quantify the differences between document using term weighting. So the concept will be more or less the same. Okay. So in the term weighting, the term of a document are not equally useful for describing the document content. For example, in the Boolean model, we only use 0 and 1. So but the weightage or the number of occurrence of the term is not counted. Okay. So for that reason, the term weighting is used in order to show how important certain word depending on the number of occurrence of the term. Okay, so for instance, a word which appear in all document of a collection is completely useless for retrieval. So this is another reason why they use the term weighting, in which in which a word, let me use different color. Okay, so a word may appear in all documents. So meaning that the word cannot be used to differentiate the document because that particular word exists in all of the document. So that word is useless for retrieval tasks. But on the other hand, certain word only exists in a few documents and they occur many times. So in that situation, we can use the weightage of the word in terms of number of occurrence to differentiate them from the other document. Okay, so you will see later on how this will assist the system to perform the ranking. Okay, so for term weighting, we associate a weight. So this one is referring to the weight of a particular term in document J. So this is the a particular term or a particular keyword I that occur in document J. So we use this one I and J. So the I is referring to keyword I, and then the J is referring to document J. So meaning that the weightage for keyword I in document J. Okay. So the this Wij quantify the importance of the index term Ki for describing the content of document J. Okay. So we use this symbol. Okay. So for instance, if we have a keyword I be an index term in document J, so we have a vocabulary of up to T, where T is the number of unique keyword that you have. So for example, the weightage must be 0 and greater. So you cannot have a negative value. So 0 means they do not occur in that particular document. Some of them is greater than 0, meaning that they have the degree of importance is determined by the weightage. So for example, like this, we have the vocabulary of T index term. We have up to T. And then for, this is a specific document J. So we are saying that for all the word, no, for all the keyword that we have up to T in this particular document J, we have the weightage. So this is referring to the weightage of keyword 1 in document J. And then this one is the weightage for keyword T in document J. Okay. So we will represent the document as a vector. So this is a vector as a series of weightage. So we have weightage 1 for document J. So this is weightage for keyword 1 in document J. This is weightage keyword 2 for document J, and so on. Okay, so that's how we interpret the weightage. Okay. So how do we compute the weightage for a keyword in document J? So we use the number of occurrence or the frequency of occurrence of the term within the document. Okay, so if there exists 5 times in a document, so the weightage will be 5. Okay. So so now we change the notation here. So this is word. So this is referring to the frequency of keyword I in document J. Okay. So that's how we read this one. This is the frequency of occurrence index term KI in document J. Okay. So the total frequency of occurrence capital I of term Ki in the collection is defined as this. So this is referring to how many times that keyword I exists in all of the document. So this is the total number of occurrence of the keyword I in all of the document. So you can see that the summation here is referring to from document 1 up to n. So this is a set of collection that consists up to n document. Okay, n number of document. So the capital letter Fi referring to the total number of occurrence for feature or keyword I in the whole set of document. Okay. So for instance, we have this that document 1, document 2, and document 3. Okay, so this one says that, okay, the frequency of do in document 1 is 1, 2, only 2 lah. So for this one, the frequency of do in document 3 is 3, 1, 2, 3. Okay, and then this F referring to the total number of occurrence of do in all of this set of documents. Okay, so if we compute individually for document 1, document 2, document 3, document 4, then we just total up this and we have 8 lah. So that means this is the frequency of do in all of the document D1, 2, 3, and 4. So this small letter n referring to um, the number of do in the number of document that consists keyword do. So only 3 document has the keyword do. Okay. Um, okay. So any question? Okay. Beatrice and Farah, you feel comfortable with this?
Okay.
Okay. So
Good.
the next one is term correlation metric, but this one we will cover more into the how to find two terms that highly correlated to each other. Okay, but we will cover this one in another lecture. But just to give you a review, so we can also find two terms that are highly correlated to each other because in term correlation matrix, we have the formula to find out which two terms are closely related to each other. Okay, so for example, we have a computer network. So this one always come together, or software engineering and so on. So for instance, we have, let me show you the formula. So this is looks familiar, kan? So this one is term document matrix. So we have the weightage of keyword 1 in document 1. This is the weightage of keyword 1 in document 2. Okay. So if you want to find the correlation between the keyword, so we just get the transpose of this. This is row column, we terbalikan dia pergi column row lah. Okay, so that is the transpose of the matrix. Okay, so when we multiply these two, we get this one. So basically, we take this one, multiply with this. So W11 multiply with W11, and then W12 multiply with W12, and then you add up them together. So this is the weightage. Okay, so you repeat again this one with this one. So that one will be in here. Okay, and then lastly you repeat the other one, the last one for that row. Okay, so this one with this one, and then you get here. Okay, and then the next round will be this one, and then this one again lah, which is below here. So once you have this matrix, so what you can do is you find the highest value that you have in this matrix. So that highest value will indicate that the two keywords are closely, highly correlated. Okay, so for example, like this. So this one, we are saying that keyword 1 exists in document 1 and so on. So we get the transpose, and then we perform the multiplication, and then we finalize with this. But we can see that this is higher compared to the other one. So we are saying that keyword 3 and keyword 4 are highly correlated in the document. Okay, so this is the example of this calculation, but we will study further about this later on. Okay, so the term-term correlation matrix is used to find two terms that are highly correlated. Okay, so so the idea that you need to understand is this one. Okay, so each keyword will have their punya own weightage and referring to certain document. Okay, but in this case, we are looking at the occurrence of the keyword. Okay, so now we go to the next new model. The reason why we have this model is that in the previous model, if that particular keyword exists in all of the document, we will not be able to perform the ranking correctly, because we need to remove the word that exists in all of the document. Like I mentioned just now, if a particular word exists in all of the document, we cannot use that word to differentiate the document, because semua pun ada that particular word, kan? So we need to cancel out the weightage for that particular word. So that's why they introduced this one, inverse document frequency. So let me show you what is the formula. Okay. So TF refer to term frequency, number of occurrence of that term, and then this one is referring to the factor that we need to compute with respect to the number of document that consist that particular term. Okay, let me show you the formula. Okay. So for the term frequency here, so we are looking at keyword I in document J. So this is similar to what you have seen before. So we use TF lah, term frequency. Okay, and sometimes they use this variant of term frequency in which they uh, do the log of that frequency and you add 1. If the frequency of that keyword in document J is greater than 0, meaning that that keyword exists in the document. So this is just a variant of term frequency. You can use term frequency or you can use this. Okay. So this is log 2. Okay, so remember that in all of the calculation that we have in this course, we use log base 2. Okay, so the log expression is the, the the log expression is the preferred form because it makes okay. Um, this one is preferred because it makes them directly comparable to the IDF weight. So we will discuss later on lah. Because the IDF ni they use log juga dalam tu. Okay. So for example, okay. So for example, like this, this is the number of occurrence of 2 in document 1. This is number of occurrence of word 2 dalam document 2. Okay, so how do we convert them? This is in term of TFIJ. Okay, so but the TF is only the term frequency. This is we are using log 2. Okay, 1 plus. Okay, so how do we find this one? First, let's have a look at 2. Okay, in document 1. So in document 1 we have 1, 2, 3, 4. So the term frequency for 2 is 4. Okay, so if we convert to the term frequency log, so basically this is the 4 just now, and then if we perform the log to 4, we will get 3. So that's how we get 3 here. Let me erase that. Too many lines. Okay, okay, so how do we get this? How do we get this? So basically we are looking for do in document 3. Okay, so in document 3 we have how many do? 3. Okay, so to compute the term frequency for do do in, okay, so this is 2 in document 3. Basically we have 1 plus log 2 3. Okay, sorry, panjang 3 dia. Okay, so this turned out to be 2.58. So that's why we get this value. Okay, so if you perform the log 2 3 lah, so this is how you convert them because log base 10 is easier to compute. So we just get this one 1.58, which is the value for this, and plus 1, so we get this. Okay, so all the value that we have in this table, we use the variant of term frequency, which is the one that using log 2. Okay, boleh paham? How do we get the number here? Okay kah?
Doktor,
Yes.
yang first kali yang log 4 tu kan, 4 tu dari mana tadi?
Yang 4 ni dia refer to, okay, we are looking at the term 2 kan dalam document 1 kan sini. So yang 4 ni is number of occurrence for this 2 dalam document 1. So document 1 here, and then 2 is how many time? 1, 2, 3, 4.
Oh,
So when we compute this one, then we get 3 lah. So that's how the 3 is here, because this one is referring to the term frequency of 2 dalam document 1.
1. Okay.
Okay. So similar to this, so this one we are looking at this keyword in document 2. So where is document 2? Document 2 is here. So B is how many? 1,
2.
2. Okay. So when we perform this one, 1 plus log 2. So log 2 is 1 kan? So 1 plus 1 lah.
Yes.
So become 2. So that's why we have 2 here. Okay. So basically the formula is 1 plus log 2, and this is the number of occurrence of that particular word in that particular document. So you just find the number of occurrence in it lah. You plug in saja lah, and then you compute. Okay. So this knowledge is very important because later on, for all the calculation, we will use this. So bukan kita use the term frequency, we will use this variant. Okay. So that's why you need to know how to compute the log 2 and then the number of occurrence here. So this is only the term frequency. So remember that in this model we have term frequency and inverse document frequency. So at the moment, what you have in this table is only this. Okay. So we need to introduce the inverse document frequency because sometimes that particular word exists in all of the document. For example, let me give you this example. Let me erase this. So basically what we have in this table is the weightage of all the term that we have in all of the documents. So this is all your document 1 up to document 4. Okay. So as you can see, this particular word that exists in all of this document. So this word B cannot be used to differentiate the document. So what we need to do is we need to cancel out this, make them to 0. Okay. So the only way we can make this one to become 0 is that we need to multiply them with 0. Okay. But how do we get this number 0? So that's why we have this IDF. They said that, okay, let key word I be the term that exists in NI document out of n document. So the IDF can be calculated as this one. So this is log 2. Okay. So for example, tadi itu we have four document kan. So we have total log 2. We have 4 document. And then for the keyword B, okay, we are talking about IDF untuk keyword B. So the number of document that consists of B is 4. So this is 4. Okay. So when we have this log to 1, this is equal to 0. Okay. So the IDF for the word B will be 0. So that's how we can times this one with 0. Okay. So for example, the IDF for this B will be 0 because this is log 2. We have 4 number of document, 1, 2, 3, 4. And then this one referring to, because we have B here, we have B here, we have B here, and B. So that means the number of document that consists BE is 4 also. So in that case, we have 4. And this is 0. Okay. Okay, how do we get this? Okay, so we have log 2. This is fixed for document. Okay, for now, for these two, how many document we have? 1, 2. So only 2 kan? Betul? Okay, so
2.
2 kan? So
Yes.
this one turn out to be 2 kan? So log 2, 2, you get 1. Okay. Okay, let's find out how do we get this one. Okay, so this is the IDF for what? So log 2, we have 4 document. And how many document consists this word? What? This one don't have, this one yes, this one don't have, this one don't have kan? So 1. Okay. So if you simplify this, log 2, 4, this is equivalent to 2. Okay. So that's how you get all this IDF. Huh? Okay. So now once we have computed the inverse document frequency, we can know that if you have the number of document is equal to the number, no, if you find the number of document that consists the keyword is equal to the number of document that we have in the whole set of collection, they will become 0. Okay, so with this weightage, we multiply them with the term frequency tadi itu. So tadi, this is term frequency ij, and then this one is the IDF for I. So this is the IDF tool. So how do we apply in quantifying the weightage? Okay. So remember that this is what we get in the term frequency. And this is the one that we get from the inverse document frequency. Okay. So for each of these line, we multiply with this IDF. Okay. So for example, this we times with 1 because we get here. So we multiply with 1, we get same. So now we take this and then we multiply with this 2. And then also here and all for this baris. So that's why we get this value. Okay, so what we get is 2 times 0.45, then we get this. Okay, and for this one also, we take that one 2.585 times 0.415, so we will get that one. Okay? So one thing that you need to notice that what happened to this, all of them will be multiplied with 0, so we have cancelled out this one, because the b, since b exists in all of the document, now we have them cancel out, so no more weightage there. Okay, so that's why we have to use the IDF to tell the system that if you have a wood that exists in all of the document, do not give them weightage. So just cancel out to become 0. But it will not affect the rest of the weightage. And in fact, they tolong lagi, because if you look at this one, this is big number. Why this is big number? Because they only exist in document. No, okay, here. If you look at here, the smaller is the number, the bigger is the value of IDF that you have. Okay, if you have big number like 4 and 3, you have a small IDF. But if you have bigger, meaning that they exist one, so you have bigger. So they will multiply the initial weightage. They make it bigger. Okay. Okay. Any question? So this is very important, because this is the basic of um, term TF IDF weighting scheme. So first they compute the term frequency using the variant of term frequency, and then we compute the IDF for each of the term that we have, and then we multiply them to form this. So this is what we call it TF IDF matrix, because we have uh, computed the TF and also the IDF, and then we multiply them to get the final matrix. So this is TF IDF matrix. And then based on this, we can perform the um, computing the distance between two documents. Okay. Any question? Or you don't feel comfortable?
Oke.
Okay.
Ada banyak latihan baru boleh Pak.
Ya. Mau the end of the session adalah latihan lah. Okay. But you need to do it on your own, but very easy one. Okay. But there is another issue that we need to look into, is that because sometimes the number of words that we have in the document ada yang pendek, ada yang panjang. So we need to normalize the term based on the length of the document. Okay? So since the document size might vary widely, so we have to perform some kind of calculation in order to normalize our term. So we call it document length normalization. We normalize using the size of the document. Okay, how do we normalize them? So we can normalize them using size in bytes. So consider that each document is represented simply as a stream of bytes. Or we can look at the number of words in each of the document. Or we can look at the vector norms. Documents are represented as vector of weighted terms. So we will be using this because we already have the weighted terms. So the weighted terms we are looking at this. Let me erase this. Okay, so the weighted terms, we are talking about this. Okay, so that means document 1, we have 3, 0.830, and 4. Okay, so this is the what we call vector norms. So we will use that one lah. So how do we compute? How do we use that one? So basically, this is the format that we use. So this is similar to this because we have document 1 and then we take all the weightage lah. So similar to this, we are representing each of the document vector as a vector norms, which is comprises of all the weightage for all the keyword. Okay, so the document length, okay, the size of the document can be computed by squaring this and then add up all the value. Square this plus square this and so on. Okay, so we just take the square of the weightage of each of the keyword and then we add up them together and then we take the square root. Okay, so for example, just now too. So for document 1, the size will be square root of 9 plus 0.830 square plus 4 or 16 lah, because 4 times 4. Okay, then you get some value, and that value is this one, this one. So how do we get because in document 1, this is the vector and the size will be square root of 3 square plus berapa tadi? 0.83 square plus 4 square. Okay, so let me confirm that one. So basically we have 9 plus 16 plus 0.83 square. Oh, okay, so you can double check lah. That one is 5.068 lah. So this is 5.068. Okay, so this is the vector norms for the document 1, and then we use that one to normalize later on. Okay. Okay. So since we are talking about the vector here, so we will shift to the vector model. So basically, they are using the concept that we have left here. So each of the document is represented as a vector of weightage. So that's why they call it the vector model. So from the term weighting model to the vector model. Okay, so we will be using the term weighting. Okay. So we will use the same concept here. So this is the weightage for keyword I in document J. and this is the vector model that we have, and this is the query. This is the query that we have. Okay, so you know how to compute this, where this is represented of TF IDF. This is for term frequency 1 for document J, and then this is IDF for 1. Let me write this one bigger. So the weightage keyword 1 in document J, this is term frequency for keyword 1 in document J times the IDF for keyword 1. So this is what we have done before. This is this one. Okay, where this is the 3 here is basically the weightage for 2 in document 1, or this is equivalent to the weightage of keyword 1 in document 1. Okay, so now we represent them as a vector of weightage for each of the keyword. Okay, so based on this vector, now we can quantify the differences between the document and the query. So our idea is, if our vector of document here and the query is here, so this degree can be computed based on a formula that we can use. So this is what we call it, the cosine distance. Okay, the cosine distance of vector D, J, and Q. Okay, so this is the cosine. So basically we take the dot product of the vector, and then we also times the size of the uh, document times the size of the query. Okay, so this is the formula. Okay, how do we apply this? Let's give this one example. Okay, but before that, we have to understand the weightage that we are using here. So this is the weightage of the keyword 1 for document J. No, this is the keyword for, the weightage for keyword I for document J. This is the weightage for keyword I in the query. Okay, so this is similar to what we have before. So this is TF IJ, and this is IDF I. Okay, so for the query, we will treat them the same also. So this is the IDF. So this is similar to this, but this one we are looking at the frequency of the term I in the query. Okay, so let me show you how we use that one. Okay, for example, we have a query to do here. So our query is to and do. Okay, so the formula for the query, let me, this one has been shifted. Yeah, let me, okay, this is the the frequency of, okay, our query here is to do. Okay? So what we want to do is we want to find the weightage of 2 in the queue. And also we want to find the weightage of do in the queue. Terbalik, not G. Okay. So we want to find the weightage of 2 in queue and the weightage of do in queue. Okay, so what is the formula we use? We use this formula. Okay, so first we are looking at the weightage of 2. So we are looking at the weightage of 2. Okay, so how many times 2 exists in queue? Only one time. Okay, so that's why here this is 1. So this is the whole part here is trying to find the weightage for 2 in queue. And then this one is the weightage of do in queue. Okay, so the 2 exists one time here, and then the do exists one time also. But remember that our do, our IDF is 4.1, 0.415, and then our do is 1. Okay, so we will get the weightage for the 2, which is this one, and then the weightage for the do in the queue is this one. And since we are trying to find the distance between queue and document 1, document 1 we consist of 3 elements here, So basically this one is the weightage of keyword is dalam queue. Tapi our queue is only to do. Okay, so that's why this is 0. Okay, so this is the weightage of to do is in queue. So this is the weightage of to do is dalam document 1, which is this one lah. So once we have this weightage, then we can find the ranking. Okay, so this is the weightage for the query. This is the weightage for the document. Okay, so how do we compute this one? So basically we have so we have to multiply this with this, multiply this with this, and then finally this one with this. Okay, so 1 times 3, and then 4.15 times 0.83. This one is 0 lah. 4 times 0 to we just out lah. Okay, so this is what? This is the length of document 1, which is we computed here. Okay, using this formula. Basically, we are so basically we get this one by getting this square root of square root of 32 plus 0.832 plus 42. So this is the length, kan? The length of the document. So each one of these will refer to the TF-IDF lah. Okay. So when we perform the ranking using the cosine, so this is the value. So the bigger the value, the more similar they are. Okay. So this is the calculation that we get. Basically, they are the same lah. So we take this one times this, and then this one this, and then that one that. So that is only the the upper side. So this is the length of the document. Square root this times square root of this. Okay, so we get this. Okay. So the advantage of the vector model is that the term weighting improve the quality of the answer set by giving the user the chances to quantify the differences between the query and the document. And also the partial matching allows retrieval of document. Partial matching means you can have one or two keywords that can be compared to the whole document, because we can now able to compute the weightage for individual term that we have in the query and also in the document. And we use the cosine ranking to perform the ranking. And in case if you have a long or large file, so we can use the document length in order to normalize the weightage of each of the term that we have in that document. Okay. But the disadvantages is that we assume independent of index term, meaning that there is no relation between terms. Since if you look at the way we present the term document, and if you look at this one, we assume that all of them are independent, means individual term. Okay, so we do not count for to do or to do is. We just assume that individual term are all independent to each other. Okay, boleh. Mau ada latihan, kan? Okay.
Iya, sendiri buat baru boleh ingat kalau tengok. Tapi boleh paham lah, cuma mungkin sendiri kira.
Yeah. So now we have five document here. So your task is to compute the rank based on the query that we have here. So we have document 1, document 2, document 3, document 4, and document 5. Okay. So when you try to finalize the vocabulary, so we ignore this. This is stop word, kan? So we don't need this one. We don't need this one no need. This one no need. This one no need. And also this one also we don't need, because they are stop word. They carry no meaning. So at the same time also, for the locate, we have this and this. So you don't count them as two different terms, because we assume we perform the stemming, kan? So this one will become locate, where we trim that one to have root of the word only. So this one is also locate. Okay. So this is your task. So the first thing that you need to do is you need to construct a table that consists of the frequency of the term that we have. So for example, you have university. So I'm just helping you to get started. Okay, university. And then we have how many documents? We have document 1, document 2, and document 3, document 4, document 5. Okay. So for document 1, we have university 1 time, 2, 1, 1, 1. Okay. So we have gone with that one. So the next one is Malaysia. So Malaysia exists 1 time here, and then here, this is none, none, and here. Okay, so we have done that one. Okay, then we have Sabah again. So Sabah exists in document 1, 0 in second document, 1 in document 3, 1 in document 4, and 1 in document 5. Okay, and then we have locate. So locate, we have 1 in document 1, 1 in document 2, 1 in document 3, 1 in document 4, and 1 in document 5. Okay, and then Kota. So Kota exists 1 time, and then 1 time also in, and then we have 0 in the third document, 0 in the fourth document, 0 in the fifth document. Okay, and then we have Kinabalu. So Kinabalu, we have 1. In document 2, we have 0, 0, 0, 0. Okay, so we're done with that one. So we start with this one. We already counted this one also, this one also, this one also. So the unique one is science. So science exists in the second document, but not in the rest of the document. Okay. Baru. So we have Baru. So only exists in the second document. Okay. So we cover this one or cover this. Okay. Malaya again. So Malaya exists in the third document and also fourth document. Okay. So we have done that, that, that. Okay. So this is your term frequency. Okay. So you need to convert them into the term frequency using the log, and you need to compute the IDF for all of these terms. Okay, and then you construct the TF-IDF. Once you construct the TF-IDF, then you need to, okay, this is your Q. So your Q, you need to find this, the weightage of the quota in Q. Okay, and also the weightage of Sabah in Q. Then Of course, each row here, no, each column here will be the weightage of the individual document that you have here. Okay, so you just follow exactly what we have here. Yeah. Okay, you buat dulu lah, then we will go over lah. Boleh buat kan before Saturday?
Cubalah. Follow saja yang instruction tu kan.
Ya, follow saja yang step by step tu kan. So,
Okay.
so sudah tererase yang tadi tu. Jadi, tapi you tengok balik the video lah kan. Okay, so you construct the best TF yang term frequency. Basically you start di sini tu. Sini. But this one is already in the using the variant of the term frequency. Okay, so you need to compute the IDF, then you have to multiply to construct this, and then from this, then you can look at the vector for each of the document. Okay, so remember that the way we say something like this kan, so the document J, let me here, we don't put the magnitude. The magnitude is just telling you the length of the document. So we do not want to know this one. So basically what we have here is that so this is represented by the weightage of 2 dalam document. No, we just put 1 here. Okay, and then the weightage of do. Do in 1, and then the weightage of is dalam document 1, and then the weightage of B in document 1. So we will continue until sampai habis ini tu. So we will continue until the weightage of it dalam 1. Okay. Tapi since the rest of them is 0, so that's why we only list 3 of them here. So that's why we just list only 3 here. Because the rest is 0 kan. Tapi for this one, they have 6. So you must have 6 weightage here. And then for document 3, we have 5. Okay, and lastly, the document 4, we have 4. Okay. Okay. So I give you until Saturday lah. You pelan-pelan buat nih. Then we will go over this one lah. Okay.
Okay, Dokter.
Okay. So I think that's all for tonight lah. Takut terlampau stres, nanti bingung-bingung.
Oke. Oke, boleh.
Okay. See you next
Thank you,
time.
dokter.
Yeah,
Oke. Thank you.
Thank you, dokter.
welcome.